There is a strange comfort in believing that luck is wild and untamed, that chance moves without rules, that the roll of a die or the turn of a card answers to nothing but fate. For most of human history, this belief felt natural. Storms arrived without warning. Illness struck without reason. Fortunes rose and collapsed overnight. To the human mind, the world appeared ruled by whim, and yet hidden beneath the noise of uncertainty. There was always a quiet structure. Probability is the story of how humanity slowly discovered that chance is not random. Long before probability was a branch of mathematics, it lived in taverns, marketplaces, and gambling halls. Dice were thrown, cards were dealt, wagers were placed, losses were blamed on bad luck, wins were celebrated as destiny. But gamblers are observant people. Money sharpens attention. Patterns began to whisper. Some outcomes appeared more often than others. Certain strategies lost consistently. Others survived longer than expected. The games felt chaotic, but they were not completely unpredictable. No one knew why. Yet, the earliest gamblers did not seek truth. They sought advantage. They wanted to know when to bet, when to stop, and how to tilt uncertainty in their favor. What they accidentally uncovered was something far more powerful than winning streaks. They uncovered structure and chance. This was dangerous knowledge, because if chance could be understood, then fate itself was no longer sacred. The turning point came when questions of gambling reached scholars instead of taverns. A simple dispute over how to fairly divide winnings from an unfinished game forced mathematicians to confront randomness seriously for the first time. That question traveled to two minds who would change history. Blaise Pascal and Pierre de Fermat. They were not gamblers. They were thinkers, and what they realized was extraordinary. Luck could be measured. Their insight was subtle but revolutionary. Instead of asking what will happen, they asked what could happen, and how often. They began listing all possible outcomes, not as guesses, but as a complete logical space. Suddenly, chance had boundaries. Randomness had shape. Uncertainty became something countable. This shift changed everything. Probability did not eliminate uncertainty. It reframed it. Instead of demanding certainty, probability accepted uncertainty as the starting point and asked a different question. Given what we know, what should we expect? This single change transformed mathematics from a language of absolutes into a language of expectations. And with that, it transformed the world. At first, probability was viewed with suspicion. Many scholars found it unsettling. Mathematics was supposed to deliver certainty, not likelihoods, truth, not averages. Probability felt like compromise, but reality demanded it. Nature rarely speaks in guarantees. It speaks in tendencies. Rain does. Not promise, it suggests. Disease does not announce, it risks. Life itself unfolds, not as a script, but as a distribution of possibilities. As probability matured, it quietly left gambling tables and entered society itself. Merchants realized that risk could be priced. Insurance emerged not as a moral promise, but as a mathematical one. Losses could be absorbed if they were spread across many people, many events, many chances. Probability made risk manageable, not because it eliminated danger, but because it understood it. Then came weather. For centuries, storms were acts of gods. Prediction was superstition. But patterns in atmospheric data revealed something astonishing. Weather is chaotic, but not arbitrary. Forecasts do not predict exact futures. They estimate, likelihoodds. A chance of rain is not indecision. It is honesty. Medicine followed the same path. No treatment works always. No diagnosis is perfect. But probabilities allow doctors to weigh outcomes, compare risks, and choose actions that improve chances rather than chase certainty. Probability did not weaken medicine. It made it humane. Then, quietly, probability stepped into the age of machines. Modern artificial intelligence does not think in certainties. It learns in probabilities. Every prediction, recommendation, and classification is a statement of likelihood, not truth. Machines trained on data do not say this is. They say this is likely. This is not a limitation. It is a reflection of reality. And here lies the deepest misunderstanding about probability. Many people believe probability describes ignorance, that it exists only because we do not know enough. But probability is not the absence of knowledge. It is the structure of knowledge under uncertainty. Even when all rules are known, outcomes can remain unpredictable. Even perfect understanding does not guarantee control. This is not failure. It is nature. Consider the flip of a coin. It feels random, but every flip obeys physical laws. Motion, force, air resistance. In principle, the outcome is determined. In practice, it is unknowable. Probability exists in this gap between determinism and knowledge. It is not chaos. It is humility. Formalized, the most profound insight probability offers is this: randomness does not mean meaninglessness. Patterns emerge not despite randomness, but because of it. Large numbers smooth chaos. Repetition reveals structure. Noise becomes signal when viewed correctly. This is why probability works, not by denying uncertainty, but by embracing it. Probability teaches a difficult lesson. We are uncomfortable with uncertainty. We crave guarantees. We prefer yes or no, true or false, win or lose. Probability refuses such simplicity. It asks us to think in shades, to act wisely without certainty, to accept that prediction is not prophecy. This lesson is not mathematical alone. It's philosophical. It shapes how we insure our homes, design systems, diagnose illness, and train machines. It shapes how societies plan, how economies function, and how science advances. Probability does not promise safety. It offers preparedness. So when someone says chance is random, they are half right. Chance feels random, but probability reveals that. Beneath randomness lies structure not perfect, not controllable. But real luck is not magic. It is mathematics we do not see. Probability does not tell us what'll happen. It tells us how to live intelligently in a world that refuses to promise anything. And that may be one of the most powerful ideas mathematics has ever given us. Stay curious. This is MathsWhisperer.